Okay, so I'm making this video because a few of you have asked me about combinations and permutations. Um, about combinations and permutations as it relates to when you're doing some SAT2 prep. So here's a quick lesson on what counting is. Because a lot of times in those probability questions, well, for probability, you need to know number of outcomes you want, and then divide it by the number of total outcomes. And so when you're trying to find the probability, you divide these two numbers. But to figure out what these numbers are, sometimes you need to know how to count really well on all the possibilities that exist. So we'll go through a few different ways to count. The first thing is called the general multiplication principle. And that's kind of this rule that you can use to find the probability of events that are just happening when you can pick from them. So, for example, we have a coin that's flipped 2 times. What are all the possible outcomes? Well, there are a few different ways I can think about this. Either I can just write out all the possibilities. So the first time I could flip a heads and then I could flip another heads. Or I could do a heads and a tails. Or I could do a tails and a heads. Or I could do a tails and a tails. So that's one way I can think about this. And I have four outcomes possible. The other way I could do this is make something called a tree diagram, where I start off with putting a dot as like my starting point, and I flip my first coin. The first coin can either go heads or tails. And then after this coin is flipped, I can flip again and again, get heads or tails. Or I can flip again and again, get heads or tails. So in the end, I get heads, heads, I get heads, tails, I get tails, heads, or tails, tails. Again, 4 outcomes. What this helps us get to is this multiplication idea. Basically, that's what this is doing. I had a split into 2, and then each of those things split into 2 again. I can think about this as I have 2 things happening. I'm flipping 2 coins, or I'm flipping the same coin 2 times. The first time I flip it, I have 2 possible outcomes, either heads or tails. The second time I flip it, again I have 2 possible outcomes, heads or tails. So I can multiply those 2 and get 4 outcomes. So for example, if we look at this next one, we have a 4-digit combination alphanumeric lock. The first digit can only be 1 through 9. The second and third digits can be 0 through 9. And the last digit can only be an alphabet. So we have 1, 2, 3, 4 options. And then from 1 to 9, we have 9 options. Then we have 10 options from 0 to 9 for both of them. And then we have 26 options for the alphabet. So we're listing in each possibility we have for each slot that we're filling in. And then we multiply it all together and we get 23,400. Another way to do this is supposing you have the only digits from 0 to 9 for 5 digits, but now you can't repeat a number. So if you've used a number, you can't use it again. Well, the first time you have 10 options. You can pick any number between 0 and 9. But once you pick a number, now you don't have that option anymore. So supposing I picked 5, now I can only pick 0 through 4 or 6 through 9. So I only have 9 options. Now I've picked 2 numbers, so I only have 8 options, then I only have 7 options, and then I only have 6 options. So I multiply all of those together, and I get 30,240 from that. So this is the general multiplying rule. This is the main basis rule that we'll use for all of this counting stuff, is basically think of the outcomes for each thing that you need and then multiply them together to get the total number of possibilities. So here's a practice problem. So you have a menu at a restaurant. It's a fixed price dinner. You can get a first course, second course, and third course. And you can pick one from each course. So how many different types of meals could we order? Well, so pause the video, do it on your own, and I'll go over it again. I'm going to go over this problem. So for the first course, second course, and third course, I'm going to put in slots for that. For the first course, I have 3 different options. For the second course, I have 4 different options. And for the third course, I have 2 different options. So then I multiply these together, I get 24 different meals I could order. And now I could try listing these out, but that's going to take a long time, and it's possible that I might skip a few or miss something. So doing it this way ensures that I'm going to get the exact number of possibilities. So now let's move on into when we get a little more complicated in counting. So this is where permutations and combinations come in. Now these are 2 big words that mean slightly different things. And so think of the difference. This is what I think of. Think about buying ice cream. So if you bought an ice cream sundae with 3 scoops in it, you could buy it in a bowl. And in a bowl, if I have my 3 scoops, I can have a strawberry scoop, I can have a pistachio scoop, and I can have, I'm trying to deal with the colors, I can have a chocolate scoop. But it doesn't matter which order these scoops are put in. I have those 3 scoops, I can put it in any order. Whereas if I got a cone, now I can get a strawberry scoop, and on top of that, a pistachio scoop, and on top of that, a chocolate scoop. But the order I do this matters this time, because I could make a different cone, where now I do my pistachio scoop first, and then I do the chocolate scoop, and then I do the strawberry scoop. Whereas if I change the order in the bowl, it doesn't really matter. But if I change the order in the cone, it matters which one's on top and probably the flavor you'd eat first before you get to the other ones. And by then, the top flavor might have melted down into the bottom, right? So that probably matters a little bit. The situation of the bowl, where the order doesn't matter, is called a combination. Order does not matter. Whereas the cone, this is a permutation, where order does matter. The classic joke that goes along with this is that a combination lock should really be called a permutation lock, because in a combination lock, it matters which order you put the numbers in. So really that's a permutation, it's not a combination. There's your little silly math joke for the day. So let's do some examples with this and try to come up with a formula to write down what the permutations or combinations are of something. So let's think about this problem. We have 8 people and we want to know how many different ways we can award a first, second, and third place to them. So order matters because it matters who's first, second, or third. And we have 8 total people, we're only picking 3 of them. So for first, so let's say we have the 8 people are A, B, C, D, E, F, G, and H. Well, for first, I could do A, B, C, D, E, F, G, or H. Any one of them could get first. And let's say I give it to A. So for second, now I can't give it to A anymore. So second is going to be only these options, and I give it to B. For third, now my possibilities are C, D, E, F, G, H, and I'm going to give it to C. So that's one way I could have done this. I had 8 choices to pick for the first place. I had 7 choices, and then I had 6 choices. So overall, I had 8 times 7 times 6. I had 336 choices. So let's think about how I can make this into a formula. So I have this pattern here where I'm multiplying and I'm removing 1 each time. This is called a factorial. So if I did, for example, 8 factorial, that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Any factorial, so n factorial is n times n minus 1 times n minus 2 times so on until you get to 1. So in this case, we have this 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But we just needed 8 times 7 times 6. We need to stop it here. We don't want this bit. Well, how do I get rid of that? I can divide it, right? So if I had 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but I want the 5 times 4 times 3 times 2 times 1 to go away, I would have to divide it. And notice that this is 5 factorial. And so I get this 8 factorial divided by 5 factorial. Now, where do I get 5 from this situation? Because I talked about 3 places and 8 people. Well, 3 places, 8 people, that's what is left over after we pick the people who got the medals. Right? So after I pick the 3 people who got medals, I have 5 people left. So this is really 8 factorial divided by 8 minus 3 factorial. And so that's the way we get a permutation formula going, is to say if we have let's say n items and r ways to pick, or we have r items to pick, when order matters, that's called a permutation, and it's written as usually you'll see it written as this, n, p, r. So n is a subscript, then a big P, then r subscript. That's n factorial divided by n minus r factorial. So that's a permutation, where the order matters and we're picking a group of people from a larger group. So now let's say order doesn't matter. So I have 8 people who want to do a job, but I only have 3 slots for that job. It's all the same job, so it doesn't matter who gets which pick. It's just 3 people from this 8 that I need. So when I pick these people, this is more interesting because I'm going to get some redundancy. I could pick, for example, if I give the job to, let's say, person A, B, and C, that's the same as if I gave the job to B, A, and then C, or B, C, and then A, right? So I get all these redundancies where these are all the same thing because all of them are getting the same job. That wasn't true in this example because if I did B, A, C, for example, that's a different situation where now B gets first place rather than A getting first place. In this case, it doesn't matter. Whichever one I pick first really doesn't change anything. So here when I'm trying to think about it, well, initially, if I do it without the redundancy, then I have it where I have 3 choices and then 2 choices and 1 choice. However, that's not going to work totally because we need to get rid of the redundancies. So let's try to redo that. So we have, if I thought about it without the redundancy, then I get a permutation, basically. Right? I get all the possibilities. So all possibilities, that would be the permutation of it. So I'd have to do NPR. But then I need to get rid of all the redundancies because I'm going to get options like this where I get the same thing, where in a permutation it's different, but in a combination it's the same. And so I'm going to have to divide this by something. And that something is going to be the R value factorial. So we know that NPR is n factorial divided by n minus r factorial. And then we're dividing that by r factorial. So we get this formula for a combination, which is written as NCR. Picking r items from n when order doesn't matter. So in this case, I have the 8 people volunteering for the job, but I only need 3, so I need 8 choosing 3 people. So 8 combination with 3. And so I would do 8 factorial divided by 5 factorial times 3 factorial. And so that would be 8 times 7 times 6 times 5 factorial. 5 factorial times 3 times 2 times 1. The 5 factorials will cancel. And then 3 times 2 is 6, so that cancels. 8 times 7 is 56. So now I have 56 ways to do this. So I have some practice situations for you to try out. So go through all of them, do them yourself, and then I'll do them on here. So pause, do them yourself, and I'll do this. Remember that there are always going to be fewer combinations and permutations. Combinations have redundancies, so they're going to be less than the number of permutations you have. Okay. So let's look at this next one. We have 45 applicants for 3 entry-level positions at a company. So in this one, order doesn't matter because it's the same position. They're all entry-level positions. And so this would be a combination. So I need 45 C3, which would then be 45 factorial divided by 42 factorial, 3 factorial. There is a combination button on your calculator that you can use. I'm not sure exactly about the rules on calculators for your SAT2 stuff. I think you're allowed to calculate this. So there is a button on there that will do this for you instead of having to remember the factorial stuff. So if you find that button, you can use that. But this will give you 14,190. Okay, the next one. A group of 25 people are going to run a race. The top 8 finishes advance to the next round. So this one, again, order doesn't matter because it doesn't matter which order these 8 people finish it. We just need the top 8. Those top 8 could be anyone. So again, this is a combination. So 25 C8. And so I do 25 factorial, 17 factorial, 8 factorial. And I'd have to calculate that. That's 100. That's a pretty big number. Same thing here. Next one, order doesn't matter again because it's just picking 3 out of 17. It doesn't matter which one. So this would be 17 factorial divided by 4 factorial, 14 factorial times 3 factorial. And that's 680. This next one. Now here, the order matters because the 4 jobs are different jobs. So depending on how we pick them, we're putting them into different slots. So this order matters. So this is a permutation. And for a permutation, that would be 15P4, which is 15 factorial divided by 11 factorial. And that's 32,760. Again, for the next one, the top 3 runners get gold, silver, and bronze. So the gold, silver, and bronze order matters. So this is 45P3, which is 45 factorial divided by 42 factorial. Which is 85,140. Right, this is similar to this first one, 45 applicants for 3 positions. But notice here the combination, because we got rid of redundancies, was only 14,000 possibilities. Whereas here, with the redundancies added in, we had 85,000 possibilities. Same thing here, we have 4 positions, different positions, so it matters which person gets which position. So this is a permutation. And you do 40 factorial divided by 36 factorial. And you get 2193360. possibilities. So hopefully that helps give you some idea around doing combinations and permutations and what those words mean, and how you can use it and what the formula is to calculate them. Hopefully you also see how the formula comes about and why you're doing the factorials and why you're dividing by different things, to give you a sense of what these combinations and permutations are doing.